Hi, welcome back to the Network Plus Certification video series. I'm Mike Redmond, Master Trainer, here to help guide you through your successful journey of becoming a Network Plus certified technician. We're going to walk through a wide variety of topics, starting with basic network concepts all the way through network management and security. In this segment, we're going to talk about Ethernet basics. I'll define and describe Ethernet, explain early Ethernet implementations, and describe ways to extend and enhance Ethernet networks. Ethernet implementation was developed by Xerox in 1973. It was based on a bus topology, and the data transfer speeds were at a mere 3 megabits per second. The next iteration came a few years later, approximately 1979, and it was called the Dix Standard, the Digital Equipment Intel Xerox Standard. It increased data transfer speeds all the way up to 10 megabits per second. However, about a year later, the IEEE was formed. So Dix transferred control of the Ethernet standard to the IEEE consortium. They created the 802.3, now known as Ethernet subcommittee. The earliest version of Ethernet out of the IEEE was the 10BASE-T, because it used unshielded twisted pair cabling. Ethernet is based on CSMA-CD. I'll explain that a little bit later. We've already spoken about the topologies of network, such as the hybrid star bus, where you have a hub in the center, acting as the electronic repeater, and each connection on that hub is called a port, and each Ethernet NIC on the network is called a node. The way the hub works is it receives messages from every node on the network and then sends out those messages to every other node on the network. So previously we talked about the Ethernet frames. All networking technologies use frames. Using frames addresses two major network issues. First, it prevents any single machine from monopolizing the shared bus cable, and next, makes the process of retransmitting lost data much more efficient. Ethernet frames contain 7 core pieces: the preamble, the destination MAC address, the source MAC address, the length, the actual data itself, a pad, and a frame check sequence. So the issue that we have with this topology is security. Sniffers can order a NIC to run in what's called promiscuous mode. In promiscuous mode, that NIC processes all frames on the line. So remember, I told you that Ethernet runs on CSMA-CD. That's carrier sensing, multi-access, collision detection. So carrier sensing, each NIC on the network examines the wire before putting a frame for transmission. Multiple access, all machines have equal access to the wire, and collision detection, if two NICs transmit at the same time, a collision results. So the NIC may listen to detect for a collision. Now let's take a look at some of the early Ethernet networks. Starting with 10BASE-T, created in 1990 by the IEEE, over 99% of all networks use this or a newer version. It's nothing more than 2 or more computers connected to a central hub. NICs connect the wires per the 802.3 standard set by the IEEE. So how does 10BASE-T get its name? Well, it's in the technology. Speed, up to 10 megabits per second. Base, the signal type is baseband. And T, because it uses twisted pair cabling. So 10BASE-T uses twisted pair, primarily unshielded twisted pair. originally with Cat3 cable with RJ45 connectors. It's based on using two pairs of wires. One pair of wires sends the data to the hub and the other pair receives the data from the hub. The RJ45 connector was introduced with the 10-base-T architecture. Each pin in the connector connects to a single wire in the cable. Devices put voltage on the individual wires and the pins are numbered from 1 to 8. Each pin within an RJ45 connector has a particular assignment. Pins 1 and 2 send data. Pins 3 and 6 receive data. The RJ45 connector itself, you may hear called a crimp. Crimping is the act of actually installing an RJ45 connector using what's called a crimper tool. Each wire in the cable is color-coded. There are two different standards that the Network Plus expects you to know. They are the TIA 568A and the TIA 568B. Either standard is acceptable, it's just important to remain consistent on the network. Similar to the RJ45 is what we'll call a close cousin. It's the RJ11 connector. Unlike the RJ45 that uses all four pairs, the RJ11 only uses two wires, generally the blue and white wire. This is what your telephone line uses. The RJ11 connections consists of one line wired in the number 2 and 3 positions in the RJ11 connector itself, and then a second phone line wired into the 1 and 4 positions. However, 10-base-T has very specific limits and specifications. Like the distance between the hub and the computer can be no more than 100 meters. And no more than 1,024 computers can be connected to any one hub. Next, we have the 10-base-FL. It has a maximum distance of 2,000 meters between the hub and the node and is immune from EMI. The 10-base-FL is more secure because it's difficult to tap into, primarily because it's using fiber optic cables, multi-mode fiber optic cables to be specific, with ST and SC connectors. Here's a look at a typical 10-base-FL card. It is possible to connect two different types of Ethernet networks together because Ethernet is standardized. They're using the same packets, although the cabling and the hubs are different. The media converter will connect differently cabled Ethernet networks together. Now let's take a look at extending and enhancing Ethernet networks. Modern networks need a way to connect individual segments. To do this, you will use what's called the Uplink Port. The Uplink Port connects two hubs using a straight-through cable. And to make sure you don't get it confused, there will be a port on the hub identified as the Uplink Port. So with one end of the cable to the uplink in one hub and the other end in a regular port in a second hub, now you can connect the two segments. This is called daisy chaining. However, it is not recommended to daisy chain any more than 4 hubs together. And just so you know, a hierarchical hub configuration, that won't work. Next, we'll talk about crossover cables. It's another way to connect two hubs without having to use an uplink port. You'll connect via two normal ports using what's identified as a crossover cable. The crossover cable reverses the sending and receiving pairs on one end. So when you're done, this is what it should look like. The next way that we connect Ethernet segments is by using a bridge. A bridge acts like a repeater or a hub to connect two Ethernet segments together. However, it goes one step beyond a repeater or a hub. By using filtering, it stops traffic from crossing from one network to the next, as well as forwarding traffic between segments. It does this using MAC addresses. You should know that bridges operate at the data link layer. Do you remember what layer that is? When using a bridge, you can connect only two networks using the same data type of data frames. A good solution that has been replaced by another solution. However, today, you really only see a bridge used for wireless networks. We'll talk about that a little later. Next, we'll talk about switched Ethernet. So we have the trouble with hubs because every node connected to a hub is sharing the same bandwidth. Increased traffic leads to a slower network. And being that you only have 10 megabits on a 10 base T network, we had to find a more efficient way to communicate our data. To solve this, we employ a switch. While they may look very similar to a hub, they act extremely different. A switch, just like a bridge, it learns and tracks all the MAC addresses that are connected to it. That way, it ensures that it will only speak to the nodes connected directly to it. That segments the network and eases the overall broadcast congestion. This creates a point-to-point connection between two conversing computers that only requires the two of them to talk. So it effectively gives every conversation in the segment the full bandwidth of the network. So now, employing a switch, we can have a somewhat hierarchical architecture. Next, when we employ a switch, it makes CSMA-CD pretty much insignificant because you can connect switches pretty much any way you wish. There are no collisions to worry about because it's taken a large collision domain and segmented it down to a broadcast domain. It does this by using a technology called a spanning tree. This is used to prevent loops in your network.
Well, there you have it. Pretty simple, right? I know, it can be a lot of information coming at you all at once, but don't worry. I'm here to guide you every step of the way. You can do this. Just remember, study hard, lots of practice questions, and you will succeed. You will become a Network Plus certified technician. I'll see you next time.